Hi everyone. I'm super excited to let you know that I have effectively solved the problem of circular reference when it comes to modeling IDC or interest during construction. If you're a project finance modeler, you would know the problem, the circular reference problem when it comes to modeling IDC. The interest during construction depends on the loan you borrow, but the loan also depends on the interest during construction. I've solved the problem, so I'm super excited. But it's been 18 marathon hours of working on this model, so you probably don't sense it in my voice. I have this solution for two different scenarios. One scenario where the debt and equity are proportionally disbursed together to meet your capex needs. So whenever you incur capex, there's always certain amount of equity and certain proportion of debt going in. And the other is where you first incur your equity all in one go, or you incur your equity first. Once it's exhausted, banks disperse the debt. These are two scenarios I've modeled here. Let me demo this to you. Now that we have this model, basically what it means is that it's possible to model IDC or project finance without using circular reference. The first situation, I have this model where we have the capex data. The company wants, let's say, equity and debt to be in the ratio of 40-60 of the total capex. Total capex is going to be construction capex plus the IDC, right? So how do we figure out how much should be the loan so that, or what proportion of capex should come from loan so that after taking into consideration the interest, we do have effectively 60% of, in this case, of the total capex in the form of debt. This problem is relatively, I would say, mathematically possible. It was easy to solve it mathematically. I already had a solution long time back, but first time I've effectively put it together. So what we're effectively doing here, or essentially doing here, is that if debt has to be 60% of capex plus IDC, construction cost plus IDC, that means it can't be 60% of the construction cost. It has to be something else. So that is what we are working out here with a series of calculations. And I have the number here, which is going to be 51.55% of construction cost should come from debt and 48.45 should come from equity. When it comes that way, we have the debts and equity put together, which equals our total construction capex. And on this debt, when we factor in the interest part, we effectively get our total debt, which is 12,137 at the end of the construction period, which is going to be equal to my construction cost plus IDC. This model also allows you to change the proportion in terms of what percentage of IDC will be refinanced through debt, because where is the IDC going to come from? Right now I'm taking 100% of it will be funded by the bankers. We could make it 80-20, 60-40, 60% from bankers, 40% from equity holders, 25-75. You can see here, whatever number I take, eventually the final answer I get is 60%. My debt is 60% of equity or total capex. It can even be 25-75, my equity and debt distribution. This model was entirely mathematically done using mathematical equations. Took me ages to solve these equations. I was almost there like 2 years back. Yesterday managed to solve this. The second is a more complex situation where we are essentially saying that, let's say I want same 40-60, 40% equity and 60% debt of the total capex. But here what we're saying is, whatever is your capex, initially all the capex will be funded through equity. Once the equity is fully exhausted, then bankers will start disbursing the loan. Here the challenge is that not just the debt amount is unknown, even the timing of the debt is unknown, because if I have less equity, then I'll be borrowing the debt early. If I have more equity, I'll be borrowing the debt late. So we neither know the amount nor know the timing. Very challenging. For now, I have solved it using recursive lambda in Excel. You could solve it through scripts. You could solve it through VBA. This is the lambda that basically what it does is this lambda takes into consideration our capex number, interest rate, what percentage of total capex we want to be in debt, and same way like what we did earlier in terms of for the IDC, how much of the IDC is going to come through debt. This model also allows for taking different interest rate for the IDC refinancing. So which means it is possible for me to say that the interest will be refinanced through a separate tranche of loan, and that will carry a different interest rate, let's say 15%. It works that ways. You could change how much of IDC will be funded through equity, how much will be funded through debt. We can also play with that. Under all circumstances, our debt will be equal to 60% of roll capex, or whatever percentage we want. If you want 25, 75, again, you could see that it's working. So I'm very elated. It's been years and years of hard work solving equations, writing programs. Eventually, yesterday I thought, I need to finish this. November 26th, 2023, I sat together with my pen, paper and my laptop, 18 hours marathon. It's done at last. But I would still not say it's done. If you're a financial modeler, I would say, if you think some more variables have to be incorporated, do you come across more variables in your models? Let me know. I can already think of one, which is VGF. If you have some other variables you could think of, let me know, and we will try to incorporate that as well. Right. I know a lot of you would want this model for your reference. I'm still contemplating what to do with the model. It's been less than an hour since I finished it, and I'm thinking about whether I should probably publish this as paper first and then circulate it. I don't want my IP to get misappropriated. The other option I'm considering is to commercialize the model. I'm also happy to circulate to wider section, just send it to public at large. But yeah, I don't want people to misappropriate my IP, and I don't want somebody else to put their stamp on this. I will publicly circulate this if I see large, and by large I'm talking about really large number of analysts showing interest and acknowledgement. So you could engage with this post, with this video. You could drop in comments in terms of what variables you want. You could like the video, share it, subscribe to the channel, forward the video to your colleagues. If I see that there is a substantial critical mass that's reached, a lot of people this message has reached, and where I know that it's not going to be easy for people to misappropriate the IP, I will definitely share the model to public at large as well. In the meanwhile, if you are a publisher of a journal, you want this paper, you are happy to consider publishing this paper in your journal, let me know. I will be really happy. And if you're any enterprise who want this solution for your project finance models, you're willing to talk on commercial terms, you want to take this model, I'm happy to engage as well. You can reach out to me through the comment section or through the email ID that I'll be posting at the end of the video. You will see it in the signature. Yeah. All right, everyone. Thank you very much. It's been a great 18 hours, and I hope I'm not hallucinating. I hope this works. Thank you. Thank you very much. Bye-bye.